All right, how are you today? We are going to talk about how to combine functions. Let's say I've got a couple of different functions and I want to put them together in some way or another. That's what we're going to do in this video. We may decide to add them or subtract them or multiply them or divide them, but any of those ways are a combination of some type. So let's start by looking at some notation, all right? Let's say I've got something like this, f plus g of x. Well, if I have two functions, f of x and g of x, all that means is I'm taking f of x and I'm adding it to g of x. Okay? So what do you think that this one means? F minus g of x. Well, that just means that I'm taking those two functions and subtracting them. And keep in mind that any time that you're given something like this, you're going to be given what does f of x stand for and what does g of x stand for. Here, fg, what happens or what does it mean when we have two things butted up against each other without a plus or minus? It just means that we're multiplying them. F of x times g of x. All right? And what do you suppose this might mean? Okay, you're right. It is division. F of x divided by g of x, but we have to add this one little thing, okay? Because we know we can never divide by 0. We always just have this little caveat at the end. We say g of x cannot equal 0. So we put that together. All right, so one of the things that you'll need to be able to do is take these functions and combine them and then be able to tell what the domain of the new combined function is. And that's not very difficult if you think about it. You're taking this function with one domain and this function that may have a different domain. And the domain, when you put them together, is exactly where those domains overlap. Okay, so it's the domain of any combination of functions is the set of all values that is common to both functions that are being combined. Okay, so what's another word for that? When you have two sets and we're talking about the things that are common to both, do you remember what the name of that is? That's called the intersection of the domains. Okay, and we use, you remember using this little upside down U for intersection? Okay. Okay, so let's take a few minutes and we're going to play around with these functions. You see we've got f of x, g of x, h of x, and c of x. We're going to use those functions and combine them in different ways. We are going to do some adding, subtracting, multiplying, and dividing, and we're going to find the domains. So do you remember I said the domain of the new function is the overlap or the intersection of the functions that we're putting together? Well, that means it's probably going to be helpful for us to know what the domain of our original functions are. So let's go ahead and take a second and come up with that, all right? Remember we talked about how to find the domain of a function. And remember that there were a couple things that we wanted to look for, and those things would indicate there were some exclusions to the domain of all real numbers. Remember that if there's a fraction that has a variable in the denominator, then there may be some exclusions where the denominator is equal to 0. Remember that if there's a logarithm, we can only take a logarithm of something that's positive. So we would want to watch for that. And when we have a radical, an even indexed radical, we would want to make sure that the radicand is not negative, okay? So it can be positive or 0, but not negative. So with these four functions, 2 of them don't have any of that stuff going on. 2 of them have no logs, no fractions, no radicals, so their domain is going to be the set of all real numbers, or from negative infinity to positive infinity. Okay? Now the other 2, they have radicals, so we want to take that radicand and make sure that it's not negative. In other words, take the radicand and set it greater than or equal to 0. So let's do that. 2x minus 1 is greater than or equal to 0. And we'll solve for x by adding 1 on both sides. 2x is greater than or equal to 1. And then dividing by 2, x is greater than or equal to 1/2. Well, if I'm thinking about that on a number line, here's 1/2, and we're going this direction. We're going greater than 1/2. So the interval there would be 1/2 to infinity. Now over here, we would do the same thing. It's a little bit easier radicand to work with, but x plus 3 greater than or equal to 0. So x is greater than or equal to -3. And here on the number line, we've got -3. We're going greater than -3, so we're going in that direction. And so that interval is -3 to 0. Oh, I'm sorry, to infinity. Okay. So let's go ahead and add, subtract. We've got some adding, some subtracting, and some multiplying here. We've got, and I think in these first few, we're only going to be using f, g, and h. So let's look first at g plus h. That means that what I'm doing is I'm taking g of x, right? And I'm adding it to h of x. Fantastic. Let's take g of x, which is x plus 5, right? And let's add it to h of x, which is x squared minus 3. All right? So now I'm going to drop my parentheses since I'm not multiplying by anything. It's always wise to keep your polynomials in parentheses to begin with, so that if we've got to distribute anything, we remember to do that. But since we don't have anything in front of these parentheses, it's just really x plus 5 plus x squared minus 3. And the only thing that I'm going to do with that now is clean it up a little bit, combine like terms, and put it in standard form, which means put the terms with the highest degree to the left and the terms with the constant to the right. Okay, so x squared is going to come first, right? X is going to come next, and then I've got 5 minus 3, otherwise known, or also known as 2. And so my combination here, g plus h, is x squared plus x plus 2. Now what I want to think about is my domain. All right, let's look at what the graph looks like for the domain of g and the domain of h. If I'm thinking about g of x, we know that the domain is from negative infinity to positive infinity, otherwise known like this, right? Everything. If I'm thinking about h of x, okay, also from negative infinity to positive infinity. So where is the overlap there? Well, it's everywhere there because they're the same thing. So our domain here is going to be from negative infinity to positive infinity. Okay, let's come over here to h minus g of x. That is the same as what? You're right, h of x minus g of x. Okay, I think you might be able to do this without my help. If you think so, pause the video and then try it on your own and check your work. H of x is x squared minus 3 minus g of x, x plus 5. Okay? Now, since I have a negative here, I'm going to distribute it through. I can drop these parentheses all together, so x squared minus 3 minus x minus 5. Combine like terms, put it in standard form. X squared minus x minus 8 would be the same as h minus g of x. Now we already did the domain of combining g and h, so I know that the domain here is going to be the same, negative infinity to positive infinity. Okay, so we've got just a couple more examples left, and to finish up these couple of examples, which I think are important ones to look at for you, I've just transferred the functions right here as well as the domain. So they are on the top of your page. However, These are the two examples we're going to finish up with today. And let's just go ahead and dive in, okay? C minus f of x, same thing as what we did before. We're going to take c of x, right? And we're going to subtract f of x. So going and figuring out what c of x is, we know c of x to be the square root of x plus 3. The square root of x plus 3. And from that, we're going to subtract f of x, which is the square root of 2x minus 1. Okay, so I'm going to take those two things and subtract them. Oh, but remember what I said before, you can only add radicals if they have the same radicand, and notice these do not. So this is as much as this expression can be simplified. So we can say that c minus f of x is this expression, the square root of x plus 3 minus the square root of 2x minus 1. All right, so now we want to think about domain, and we will look at c and f. Okay, so c, we know is from negative 3 to infinity. Okay, so it looks like this, right? And f is from 1/2 to infinity this way. All right, so where do those graphs overlap? All right, so the green one starts here, but the pink one does not start until over here, and that would be where both graphs exist. And so our domain is going to be from here to infinity, otherwise known as 1/2 to infinity. All right, very good. Now, last example, and here we have a division problem. And remember that when we have a division problem, we always need to think about where would the denominator equal 0 and exclude it, right? Because that denominator can't equal 0. So let's just set this up. We'll say this is h of x divided by g of x, where g of x does not equal 0. So let's plug these things in. H of x is x squared minus 3. G of x is x plus 5. Okay? And we know that x plus 5 cannot equal 0. Okay, remember, we need to find out what x can't equal. Move that 5 to the other side by subtraction. Subtract 5 on both sides, and we can say x is not equal to negative 5. All right, so this, in addition to this restriction, in addition to what we already found out f and g is, remember we found out f and g was the set of all real numbers when we put those together? But then we got to take out negative 5. So here's negative 5, and we take that out of the set of all real numbers. So we are left with everything to the left and right of negative 5. So our domain is these two pieces on the number line. So this piece we call negative infinity to negative 5, but we don't include negative 5 because it's not included here. And negative 5 to positive infinity is this piece. So those two pieces, and we connect them with a union. Sometimes you can connect them with a comma depending on your teacher. I'm okay with either one. So those two pieces constitute our domain, because our domain was the set of all real numbers, but then we've got this little exclusion here that says it can't equal negative 5. All right, that's where we're going to wrap it up for combinations of functions, and I'll see you next time.